Hello all, hearty welcome from AVINEON and Tensing to this presentation called FME in Maintaining Spatial Data Infrastructure Database Updates. Hope all of you are staying safe and doing well. My name is Ramna, working as Senior Vice President for Consulting and Technical Solutions at AVINEON. I would be the presenter for you today. My colleague, Mr. Srikant Palatla, Senior Solution Architect, would be answering any questions you may have in the end of the presentation. If we could not answer your questions right away, we can always get back to you later on your email. So do please share your email. Let's get started with a brief introduction of AVINEON and also Tensing, which is an AVINEON holding company that specializes in consultancy, software, and training in Europe. AVINEON is a global technology company serving customers close to 30 years in the industry in the areas of geospatial, engineering, and IT services. However, the below introduction limits our experience to safe software, keeping FME worldware in focus. We are a safe silver partner since 2017, though our journey with FME started much earlier. We are having close to 30 years of data migration, conversion, and integration experience with multiple large data projects successfully executed over the years for large customers across the globe. We are recognized as one of the best-in-class FME certified teams worldwide. Our FME services include consulting for FME implementation, FME-based projects, FME-based applications development, providing training on FME, and also FME licensing. As I mentioned, AVINEON is a global technology company having offices worldwide, including North America, Europe, and Asia. Let's get started with the agenda for today's presentation topic, FME in Maintaining Spatial Data Infrastructure Database Updates. I would be presenting one of our project case studies in the area of spatial data infrastructure solution implementation, which is one of our core expertise. During this presentation, you will understand scope of the project, including business needs and objectives of the customers. We will also understand briefly what an NSDI solution concept is. We will have a brief look at solution components implemented by AVINEON, like data standards, database model, and front-end map portal. We will also understand the role of FME software in the whole solution. We will then touch upon key challenges we have overcome during the implementation. We will end the presentation with the business benefits resulted for the customer, which is followed by a question and answer session. So our customer is a national agency with spatial data standardization and dissemination responsibility across multiple stakeholders. One of the challenges they have is to deal with multiple non-standard spatial data schemas and formats, which is preventing efficient spatial data exchange between stakeholders. Whatever spatial data exchange they have currently is manual and individual file-based without a common data sharing platform or framework. As we all know, spatial data keeps changing every day on ground and gets outdated quickly unless we have a mechanism for regular data update process. Currently, data update process is isolated and manual. So that's the challenge. The important challenge is lack of data mining and discovery tools, which is resulting in redundant data sets creation as well as hindering spatial data usage in decision-making process. To overcome these business challenges, a project is taken up with the following objectives. Primary objective of this project is to develop a national spatial data standards, a data model, and a data sharing framework. Other objective is to consolidate and migrate various spatial data layers into a centralized database called National Spatial Database. Like I mentioned, the key objective is to establish a mechanism and ETL tools for automated data loading and update to keep the spatial data layers up to date from various stakeholders and multiple formats. The other objective is to promote spatial data sharing culture among stakeholders through service-oriented architecture and infrastructure. One of the key objectives is to develop front-end map portal application with data viewing and analysis and reporting capability. So let us understand briefly the concept of spatial data infrastructure and data clearinghouse. SDI can be defined as a secure spatial data sharing platform where multiple stakeholders can come together and publish spatial data services for data exchange. This enables data standardization in terms of data model, data formats, and other aspects. SDI also provides efficient data discovery and data download options for users. Another advantage is that agencies that do not have a major IT infrastructure to publish own data services can utilize SDI database infrastructure to load their data layers and publish. Once we have centralized SDI infrastructure available, agencies can develop decision support tools and host it for stakeholders to use. With this background, let us look at AVINEON solution approach. AVINEON solution approach consists of three major components: data standards, data exchange framework, and data maintenance strategy. AVINEON developed data standards and a common data model by adopting ISO-based theme, class, topic classification for all the spatial data layers. We have defined metadata templates and data ownership matrix for each layer, indicating stakeholders' responsibility for data creation and update. We have taken outreach programs to promote the data standards, data model, and data update process. Second component of our solution is establishing data exchange framework. This includes data consolidation, service consolidation, and data loading for creating a centralized NSDI database. This is where Safe Software FME played a major role in data loading and consolidation across multiple formats. Once we have the database created, we have created OpenGIS map services for consumption by various agencies. We have created map service types like WFS, which is Web Feature Service, Web Map Service, Web Catalog Service, things like that. One of the key components of our solution is developing a web map viewer application with several data viewing analysis tools that utilize the spatial data service published. Third and important component of the solution is establishing a data update framework and process. As mentioned, multiple stakeholders have data in different formats like shape, CAD, and geodatabase. We have developed FME-based ETL tool package, workflow automation for data update loading process. This way, it is ensured that NSDI database is updated regular intervals to keep the data services relevant, addressing business needs of the stakeholders. Let us take a look at the overall solution architecture and interoperability between various solution components. Data management is mostly centralized, with few stakeholders having advanced capability to directly publish map services. Source data submitted at regular intervals by stakeholders, which gets loaded into a centralized database. This process is managed using safe FME tools efficiently. The database is accessed by a server application, which publishes multiple data services for consumption. Server application also pulls data services published by advanced stakeholders for consumption by various applications like Geoportal map viewer and metadata mining and discovery applications. The applications and services are accessible for various types of users like public users, department users via web and mobile in an access controlled environment. Let us take a look at the data model and service architecture developed. Like I mentioned, we have consolidated and standardized all the spatial data layers into a common data model using ISO geodata classification standards. And we have developed ETL tools and consolidated data from various stakeholders using safe FME workbenches and created centralized spatial database. We published various data services including map services, processing services, discovery services, etc. Okay. As mentioned earlier, keeping the spatial data up to date is key for success of SDI since it is not a one-time data loading activity. Having automated and efficient tools processes is key for data update. We have used FME to have multiple tools to address the data update process. To start with, we have provided data layer templates for various stakeholders, which is configurable. These configurable templates are used by FME. Few ad hoc formats and schemas for new layers also allowed. We have developed then bunch of FME based validation tools and workbenches like schema validator, specification compliance validators. Once the data pass validators, we have another set of data transformation and loading workbenches that load the data using either append or replace modes. We also have data archive tool that archives the previous data before starting the loading process in case a rollback is needed. This whole process is packaged and runs automated once user places the data layer for update. Few sample workbenches is shown here, and this slide show the extent of validation rules configured in these workbenches. This includes feature mapping, field mapping, and domain value mappings. User can add additional layers to this configuration dynamically. And this is the few sample workbenches. This one is for hydro polygon layer transformation loading. And the technology what we have used in this project is FME Server 2019 version and FME Desktop 2019 version. In the end, for every load cycle, we will have a log file generated summarizing the features loaded. These logs report any issues encountered during loading, and these logs also sent to DB administrators automatically via email, and any failures are notified in the subject of the emails. This slide is showing the NSDI Map Your application developed by AVINEON as part of this project. This particular snapshot shows the disaster management tool. This tool consumes data from various layers, from various stakeholders, and presents one unified map view containing disaster management facilities like hospitals, educational institutions, and it also uses various topographic feature layers like village boundaries, road center lines, etc. And it also have disaster management facilities locations like boats and troops, etc. Let's take a look at the key challenges we have overcome during the implementation. Since multiple stakeholders, departments hold the legacy data in multiple schemas and formats, it is a challenge to consolidate and load into a common data model, minimizing the manual efforts. FME helped to a great extent in making this process efficient with minimal manual efforts. Other challenge is to keep the data update process as automated as possible and ensure data quality and consistency. As I explained, we were able to build automated data validation and update processes with the help of FME. Stakeholder readiness in adopting the standards and model is another challenge. We had extensive outreach and training programs to address this. One of the key concerns in data sharing is data security, particularly when data is shared via internet using services. We have put the required security controls like data encryption, service access by user credentials, multi-factor authentication for sensitive data, etc. Also, it is important to identify data that helps in day-to-day business or decision making, and make sure it is available for the users to keep the interest. Continuous interaction and requirement gathering helped in making this possible. To conclude, let us understand the key end user benefits resulting by implementing the SDA solution. Important benefit we notified is that spatial data across departments is now standardized and consistent, and there are no redundant data sets. Also, automated updated process we have put in place is ensuring up-to-date and high-quality data being made available in the SDA portal. Other key benefit is data dissemination and exchange became easy, flexible, and secure, promoting interoperability between data and stakeholders. Since data can be accessed using a web map viewer with advanced tools, and spatial data is now reaching a wider audience. Last but not the least, the availability of a technology platform and APIs is promoting the development of multiple use case tools at end user level. That concludes the presentation. Thank you for your time and attention. We would be happy to answer any questions you may have. Thank you again.